Hello, and thanks for using TickBoom. In this video I'm focusing on part 4 of this 5-part question, and it follows on directly from 3 prior videos where I worked through part 1, part 2 and part 3 in turn. So if you haven't seen those videos, I recommend you go take a look, because the nature of this question is that each part builds upon those that came before it. So you won't be able to really follow along with this part unless you've gotten your head around all those prior parts. If you have watched those videos, stick around. I'll work through part 4, which asks us to consider a similar integral to the one we looked at in part 3. And in doing that, show that for all sufficiently large positive integers n, the inequality 1 minus 1 on 2019 on 2 is less than x1 plus x2 plus all the way up to xn on n to the 2/3, which is less than 3 plus 1 on 2019 on 2. So we want to show this inequality, and we're given the hint, well, we're given 2 hints. First, that we want to look at an integral similar to the one from part 3, and we're also focused on sufficiently large positive integers n. So to start, what I'll do is I'll just write out this inequality so that we can refer to it. So we're looking at 1 minus 1 on 2019 on 2 less than x1 plus x2 all the way up to xn on n to the 2/3 less than 3 plus 1 on 2019 on 2. So with these kind of inequalities, it's often helpful to think about each side of the inequality one at a time. So I'll start by focusing on this left-hand side, the 1 minus 1 on 2019 on 2 being less than this x1 up to xn on n to the 2/3. Now, from part 3, what we know is that x1 plus x2 plus all the way up to xn, we proved that that was greater than n minus 1 to the 2/3 on 2. And we did that for n greater than or equal to 2, and we did that with reference to an integral that was 1 to the n plus 1 of x to the negative 1/3 dx. Now, if we think of a similar integral, if we consider the integral 1, and this time we'll go to n plus 2 of x to the negative 1/3 dx, very similar integral, same thing being integrated just to a different amount, then what we'll get is we can think of this result, and instead of going up to n plus 1, if we go up to n plus 2, then we've incremented by 1, so we can increment all of this, effectively inserting n plus 1 wherever we see n. So what we'll get is we'll get x1 plus x2 plus xn plus xn plus 1 will be greater than n plus 1 minus 1 on 2/3 on 2, which is greater than n to the 2/3 on 2. And I think this is getting us on the right track, because the result we're dealing with has an n on to the 2/3 in it. Now if I do some simple rearranging, we'll get x1 plus x2 plus xn is greater than n to the 2/3 on 2 minus xn plus 1. So I've just brought this xn plus 1 over. Now let's divide everything by n to the 2/3. So that's going to give us a half minus xn plus 1 on n to the 2/3. So we're very close here, because this part of the inequality matches this part. So now I just need to get this part to match this part. And something worth noting is that 1 minus 1 on 2019 on 2 is equal to a half minus 1 on 4038. And notice here I've got a half minus something and a half minus something. What that means is if this if this thing is greater than a half minus something, if that thing I'm subtracting is smaller than this, if I insert here something bigger, so I'm subtracting something bigger, then what I've got will still be greater than that result. Because if I'm greater than a half minus something and then I subtract something bigger, the inequality will still hold true. So really what I'm interested in is x n plus 1 on n to the 2/3, is that less than 1 on 40/38? Now, remember from part 1 of this question, we were able to show that xn is less than or equal to 1 divided by the cubed root of n minus 1. I think that's going to come in handy here, because if we think about, let's go to the fact that all of this is in the context of sufficiently large n. Let's look at, say, n is equal to 100,000. Then what we'll get is xn plus 1 would be x 100,001 divided by 100,000 to the 2/3. Now that would be less than or equal to, and here I've got 100,001, so I'll put in 100,000 minus 1, so it'll be less than 1 on the cubed root of 100,000 divided by 100,000 to the 2/3, and let's see what that gets us in our calculator. So I just go 100, 1, 2, 3 to the power of 1 divided by 3. I'll take the inverse and I'll store that. And then 100,000 to the power of 2 divided by 3. I'll store that. The first result divided by the second result is equal to 0.00001. Now what's 1 on 40/38? 1 divided by 40/38 is 0.002476, and so on. So we see that when n is equal to 100,000, this xn plus 1 on n to the 2/3 is less than 1 on 40/38. Now what I've had the luxury of doing, because I'm not sitting in an exam hall, is I went and then tested this for many, many more values of n. I just used an Excel spreadsheet and I was able to confirm this is true. Now you might not have that luxury in an exam, but you could make the guess, or you could kind of take a stab that this will be true. You've proved it for a fairly large value of n. Maybe you could test a few more and convince yourself. But what it means is we can now insert here the 1 on 40/38, and the inequality still holds true. And then we can rewrite it back in its original form. So we'll get a half minus 40/38 is 1 minus 1 on 2019 all on 2. And so we've got the first part of the inequality for sufficiently large n. We need n to be sufficiently large for this to be true. But just by taking our result in 3, thinking about a slightly different integral and doing a bit of rearranging and a bit of, I guess, creative thinking, we've proved the first part of this inequality. So now what we need to do is prove the second part, and I'll just turn over the page. And let's now consider another similar integral to what we had in part 3. Let's consider the integral from 1 up to n of x to the negative 1/3 dx. So instead of incrementing by 1 extra, we're now going to go 1 less. But if that's the case, let's just draw up a diagram for this. Because we're going to, using the techniques that we used in the earlier parts of this question, we're going to be able to get an inequality that will lead us to what we need to show. So we'll go 1, 2, 3, 4 up to n. We'll go 0.2, 0.4, 0.6, 0.8 and 1. Very similar to what we've done before. Let's just plot some points. So 1 to the power of anything is 1. We'll just use the calculator. If you've watched earlier videos you would have seen this, but I'll just do it again. So 1 divided by 3, I'll store that. So 2 to the power of negative a third is just under 0.8. 3 to the power of negative a third is just under 0.7. 4 to the power of negative a third is just over 0.6. And I'll just, got the general shape there. We know the integral represents the area under the curve. And like I did in the earlier parts, I'll draw rectangles. In this case, we'll do rectangles under the curve. And we'll get from this an inequality that's going to help us for the remainder of this part. So we know the area of the rectangles is less than or equal to the area of the curve. So let's just write that out. We know area of the rectangles less than or equal to the area under the curve. The rectangles will be, in this case, 1 on 2 to the third plus 1 on 3 to the third plus all the way up to 1 on n to the third is less than or equal to the integral from 1 to n of x to the negative a third dx. Let's just evaluate that integral. So we'll get x to the 2 on 3 on 2 on 3 between 1 and n, which will give us, we'll bring out the 3 on 2, n to the 2/3 minus 1. And just like before, getting a result that involves n to the 2/3 lets me know I'm on the right track because that's in the inequality that we're looking for. So once again, going back to from the result that we learned in part 1, what we know is that x to the 3 is less than or equal to 1 on, in this case it would be 3 minus 1 is 2, 2 to the third. X to the 4 is less than or equal to 1 on 3 to the third. And so on, all the way up to x to the n will be less than or equal to 1 on n minus 1 to the third. So we know that from part 1. We also know that x1 is equal to 1 and x2 is equal to 1. So that's always going to come into play. But what we can do is, let's just write out this inequality, but I'll just add a few 1s at the front. So we'll go 1 plus 1 plus 1 on 2 to the third plus 1 on 3 to the third plus, we'll go 1 on n minus 1 to the third plus 1 on n to the third. This part of it we know is less than or equal to 3 on 2 times n to the 2 on 3 minus 1. And I'll need to just add plus 1 to keep the inequality valid. So what we can then do is we can know that this part is essentially, or well actually all of this part is we can replace with the x1, x2, x3 and so on. This inequality will still hold true because all of those things are less than or equal to these numbers. So we can go x1 plus x2 plus x3 plus x4 plus all the way up to, actually, so it's only this part of the inequality, because we only go up to there. So plus xn, so that plus 1 on n to the third, that's going to be less than or equal to 3 on 2 n to the 2 on 3 minus 1 plus 1 plus 1. So I'll have to turn over the page, so I'll just rewrite this over the page. So we'll start from x1 plus x2 plus xn plus 1 on n to the third less than or equal to 3 on 2 n to the 2/3 minus 1 plus 1 plus 1. So that's kind of where we're starting. Now, if all of this is less than this, and this is going to be a positive number, if I just drop that off, the inequality still holds true. So this what's left will definitely be less than what we've got here. So what we'll say is x1 plus x2 plus all the way up to xn will be less than 3 on 2 n to the 2/3 minus 3 on 2 plus 1 plus 1. And that's going to give me less than 3 on 2 n to the 2/3 minus 1.5 plus 2 will get me plus 1/2. Now, if I then, I'm very close here, if I then divide both sides by n to the 2 on 3, we'll get x1 plus x2 plus all the way up to xn on n to the 2 on 3 will be less than 3 on 2 plus 1 on 2 n to the 2 on 3. So, like I did before, if we note that 3 plus 1 on 2019 on 2, that's equal to 3 on 2 plus 1 on the 4038. So we've got this very similar format here, and now we're concerned with the 1 on 2n to the 2 on 3 as compared with 1 on 4038. Now, again, if what I'm adding up here is smaller than this, then if I replace this with something larger, the inequality will still hold. If this is less than 3 on 2 plus something smaller, if I put something bigger there, the inequality is still true. So what I want to really think about is 1 on 2n to the 2 on 3 less than 1 on 4038? And just like before, if I think of a large number, so e.g. n is equal to 100,000 again, what do we get? 1 on 2 times 100,000 to the 2/3 is equal to, so let's do this, 100,000 to the power of 2 divided by 3 times 2, and then the reciprocal. So what I get there is 0.000232, and then the 1 on 4038, calculated it before, I'll just do it again, 1 divided by 4038 is 0.002476, so on. So this inequality is true. Just like I did before, I went and convinced myself that it stays true for bigger values of n. In an exam, you might just do a few more examples with some even bigger numbers. But what we can do is we can, like we did before, insert the 1 on 4038 and the inequality still holds true. And then we can rewrite it back in this format, since that is equal to that. Now, that's what I've just shown there is this part of the inequality. So I've demonstrated this part and I've demonstrated this part, so now we can combine them. So just to finish this off, I'll say combining the results gives, and we'll have 1 minus 1 on 2019 on 2 less than x1 plus x2 all the way up to xn on n to the 2/3 less than 3 plus 1 on 2019 on 2. And we have to confirm for sufficiently large n, because the only way I could get to these results was by using quite large values of n. So that's it for that part. That's the second last part of this 5-part question. As I mentioned in the very first video on this whole question, I am actually stuck on part 5. Part 5 continues to elude me in terms of what technique will get me to a solution. So what I'll do is I will record another video for part 5 where I just talk through some of my thinking, some of the things I'm struggling with, and really do a bit of a call to action for anyone who's worked through all these videos and followed along. If you can think of something that can solve part 5, please get in touch and let me know, because I'm really reaching out to my network to try and come up with a solution for part 5 to help the student who sent me through this question. So hopefully you have been able to follow along up into these parts 1, 2, 3 and 4, and hopefully it's all made sense and it's been clear. And I'll see you in the next video where I talk through some of the struggles I'm having with part 5. Tick boom.